Today we're going to talk about adding and subtracting radicals. Okay, so you can only combine radicals. You can only combine radicals that have the same index. Thank you. Okay, so that's talking about like the little cubbyhole. And have the same radicand. Okay, and the radicand is the guy that's underneath, and the index is the little guy in the cubbyhole. Okay. So for instance, and you can put this little index and radicand thing in here. Sorry, made it look kind of weird. Radicand. Okay, so radicand is the one that's underneath the radical. It has to have the same, I call it a base, okay? And then the index is the little number in the cubbyhole. It's either going to be a 2, which won't show up, or a 3. So to combine the radicals, you're going to add the outside and keep the same radicand. The first thing that you're always going to have to do is simplify, though, before you start combining things. Okay? So what that's going to look like is right here. Do we have the same radicand on these two things? The first example. The number underneath the radical is not the same. So what we're going to have to do is simplify 45. So let's talk about it. What are factors of 45? 5 and 5 times what gives me 45? 9. Okay. Can I break 5 down anymore? No. No. What about 9? Yes. 3 and 3, right? Now we learned yesterday, if there is a pair, they can exit the radical, right? We got to have our exit buddy. So up front, we're going to have 2 times 3 radical. What's left over? 5. And then we're going to rewrite this guy. Minus 2 times, 2 radical 5. So right here, can we combine 2 times 3? Yeah, what's 2 times 3? Okay. So now the instructions were, once they have the same index and they have the same radicand, we can just combine the things that are on the outside. So not looking at the radicand, what's 6 minus 2? 4. So this is going to be 4 radical 5. Okay, so for my visual people, what we did was we said, hey, these are the same radicands. So that's Gucci. Now we got to combine 6 minus 2. Okay. Can you take a moment? Can you try to simplify these two guys? Simplify it, and then we're going to combine it in just a second. So on this one, I'm going to look at this first part. It's all, okay, these all have the same index. The index is the number in the little cubbyhole. So for instance, since none of these have a number here, then they all are the same index. They all have the same radical. Okay, then no. Okay, so then here, do we have the same radicand, the number that's underneath the radical? No, so we can't combine anything yet. We got to simplify first. So can we break 12 down? Yeah. What? 6 and 2. Can we break down 6? So what? 3 and 2. Okay. Now we got a partner, so we can pull one out. It's multiplying, not adding, right? Okay. So we can pull 2 out. Negative 3 times 2 is what? Negative 3 times 2 is, okay, and we're left with this 3 underneath the radical. It's okay. And if you break down, I'm out. I'm so sorry. Go run to the bathroom. Yeah. Okay. You can do 3 and 4, but then when you break 4 down, you get 2 and 2. That's fine. Okay. Now, is this broken down all the way? Yeah. So we're just going to rewrite him down here. But what about this guy? Can we break 20 down? So what? Why y'all always do real big numbers? Oh. Okay, what about 10? Can we break that down? 5 and 2, which would, okay, if you did 5 and 4 at the beginning, again, same thing. We would break it down into 2 and 2. We get the same thing. All right, here's a pair. We're going to pull that 2 out. So what's 3 times 2? 3 times 2. And we're left with that 5 underneath the radical. Okay. Remember, we can only combine ones that have the same radicand. We can only combine the ones that have the same radicand. So what we're going to do is we're going to take -6 plus 3. That's going to give me -3 radical 3. Can we combine this guy with anything? Can we combine 6 radical 5 with anything? No. So we're just going to say plus 6 radical 5. On number 1, if we're trying to simplify this, this is already simplified. And then we have -2 radical 20. So let's break that down. 20 can be broken down into what factors? 10 and 2. We got to be real careful with this adding and multiplying. Remember, we're dividing. We're trying to figure out what factors work. Okay? So 10 and 2. And 10 can be broken down into 5 and 2. So if we have a pair, we can pull one out. So that's going to be 2 times -2. So this is going to give me, I'm so sorry, this is a little messy. You can't even see that. 3 radical 5 minus 4 radical 5. And then if we want to break down this 20, we get the same thing. We get, let's do 4 and 5. And this breaks down into 2 and 2. Same thing. I got a 2, multiply it times this 3 out front. And so this is going to give me 6 radical 5. So now, since all 3 have the same thing underneath the radical, we can combine everything on the outside. So what's 3 minus 4? -1. -1 plus 6 gives me +5 square root of 5. You keep the inside the same. Inside stays the same. You just combine the outside junk. What's up? Because I broke this down and I said -2 times this 2, that gave me that -4. Anything else? Okay, this next one's a little tricky because I threw something at you that you're not really used to. If I have a negative underneath the radical, what is that? No solution. Now, I know we haven't talked about this yet, and that's going to impact your answer choice down here. They got it out here. No. Okay, so number 2, we're going to simplify this. We're going to just ignore the negative right now. So really, this would be no solution, but we're going to ignore the negative. So we're going to just go ahead and scratch that guy out. Okay. All right, so let's break down this 48. What would that break down into? What factors? 8 and 6. Okay, cool. And then 8 breaks down into 4 and 2, and 2 and 2. 6 breaks down into 3 and 2. Okay, we got a pair, and then we have another pair. So that's going to give me 2 outside the radical, multiplied by this -3, and another 2 outside the radical. That's multiplied by that -3. So that's -3 times 2 times 2. So that's going to give me -12 radical 3. Can I break this guy down? Into what? Can I pull anything out though? No. So I'm just going to leave this guy alone. Okay, so we got -3 radical 6, and there's a little 3 in these cubby holes. And then can I bring 162 down? Yeah. What can I divide it by? Let's do 2. Okay. What can I break 81 down into? 9 and 9. Okay, so I see a pair. I'm going to pull out a pair, and that's going to give me 27 cubic root of 2. Can I combine any of these? Can I combine any of those? No. No, I can't. So this is the final answer. Look at what they got going on down here. I can divide everything by 3, but that's okay. Say again. It's 27 cubic root of 2 minus 3 cubic root of 6 minus 12 cubic root of 3. Now, I could technically divide everything on the outside by 3, but we're not going to talk about that just yet. Might be a little too advanced for that. So, ready? Okay, on number 7, remember, we only distribute the junk that's on the outside. Okay, so when we do this, we're going to distribute this guy to this guy. So what's -2 times 3? -6. And then what's 3 times 2? So we're going to have -6 radical 6. So we multiply what's on the outside together, and then we multiply what's on the inside together. Okay, remember, we multiply faces together and then guts together. I don't know if I used that yesterday with y'all. On this next one, what's on the outside of this radical? We got the radical 6. So what's on the outside of a radical if nothing's written there? A 1. So what's -2 times 1? And then 3 times 6? No. 3 times 6. Oh my God. 18. This is where that multiplication comes into play, right? Okay, now, can we simplify this radical 6? No. Can we simplify this radical 18? Yeah. What does that break down into? 9 and 2. And then what does 9 break down into? 3 and 3. Since we have a pair, we can pull one out. -2 times 3 gives me what? -6. And then we're left with 2 underneath the radical. So I pulled out a 3, and I multiply it times -2. So that gave me -6. And then I'm left with radical 2. On number 8, we've got negative square root of 3x times 4x. Okay, I'm gonna write all this junk up here. So sorry. Okay, so this, I'm gonna take -1 and multiply it times 4x. That's gonna give me -4x square root of 3x. Cool. Then I'm gonna multiply it times this junk over here. So that's gonna give me -x square root of 6x squared. With me? Oh, I'm sorry. Let me write it smaller. That's going to give me -x 6x squared. Yeah. Here's one thing we have not talked about really. Just ignore the x's for like 2 seconds. But look at the numbers underneath the radical. Are those going to be able to be combined? Are they the same? No, we really can't simplify it, right? But one thing that we have not talked about is we haven't talked about variables underneath the radical. So let's have this conversation. I need eyes on the board really quick, okay? If I have something like this, where I say x squared, what is the square root of x squared? X, how did you do that? So it gets rid of it, right? So if I said, take the square root of x to the 6th power. Okay, so there's 6 x's, right? And you kind of want to think about this as like, y'all taken Uber before, or you know what Uber is? Okay, so what the index is that's telling me that there can only be 2 people in an Uber. Okay, but we have 6 people trying to get into an Uber, but each Uber has to have 2 people. Well, how many Ubers are we gonna have in total? Not 4. So if we have 6 people in total, I need you to listen. We have 6 people in total. We can only take an Uber if we have 2 people. How many do we have? So this would be simplified to x to the 3rd. Exactly. Okay. Now, if we had, for instance, something like this, where we had x to the 7th, and we were doing the same thing, how many Ubers could we take? We have 7 people. And you're saying, hey, we can only put 2 in each Uber. We would have 3 Ubers with how many people would have to stay? Because they have to have a partner when they exit the radical. That makes sense? If the index was 3 instead of 2, watch what happens. Let's take that same scenario. We got a 3 in this little cubby hole now. We have 7 people. Oh my gosh. Can we know? Okay, we have 7 people. Okay. Now we can make a group of 3 when we get in the Uber. So how many Ubers are we going to take? 2. And we're going to have how many people staying at the party? 1. Does that make sense? So going back to our original problem up here, if I have an x squared right here, can I pull one of those out? Yes. Okay. So this would be negative 4x square root of 3x minus x squared square root of 6. This would be our final answer.